processes for homework 10 was also a video question. It was again about collection of definition and properties of the stochastic processes mentioned below. So there are a total of eight subparts to this, and it says explain your understanding about these properties. Okay, so we'll start with Hw10 stationary. So Hw10 stationary or WSS, it's if its mean is if the process has a constant mean and autocorrelation depends only on the time difference, then the process is said to be WSS. These are the two components that are required. So R of T1 T2 represents average power of the signal at T1. We also see that when the input is Hw10 stationary process, the output of the stable LTI system is also Hw10 stationary. Moving on to the second part, it's independent increment process. This means that x of T1 minus x of T2 and x of T3 minus x of T4 are non-overlapping intervals. On non-overlapping intervals are independent. It's basically like assume a line and 4 points and x1, T1 and T2. This time slot should be totally different and not overlapping with T3 and T4. The process like Poisson's process, random walk and Wiener process are independent increment processes and follow the Markov property. Next, this brings us to what is Markov process. So Markov process are basically, it means that suppose we are given the present value, so the future will be independent of the past value. So we can read that again. This means that given a present value, the future will be independent of the past value. Next process is the normal process. Now, by normal process, a process is said to be normal if the random variables xt1, xt2 and so on xtn are jointly normal. F of x, so its PDF is given by fx of x is x1, x2 and so on xn, t1, t2 and so on tn, which can be written as 1 by 2 pi n root dt, determinant of C is the covariance matrix, into expected value of minus half of x minus mean transpose C inverse x minus eta. You can also think of this as a two-dimensional Gaussian, if you will. Then fifth one is strict sense stationary or SSS. So the process is strict sense stationary if its statistics are not affected by the shift on the time axis. So it is independent of the shift on time. Next is white noise. So let Wiener process W of t, which we discussed in question 1 of this homework. So if we differentiate it, we get V of t, and that is the white noise. So basically, if we differentiate Wiener process, we get white noise, and its expected value is given by derivative of Wiener process, as we can see here, and which is 0. And W of this Wiener process is continuous with probability 1. And RV is basically the correlation of the white noise. T1 and T2 is basically A times of delta of T1 minus T2. So the white noise has two properties. Its mean is 0 and its covariance is given by Q of T1 into delta of T1 minus T2. Next is mean ergodic process. So basically mean ergodic process has two properties. I wrote only one here. First one was to have its mean be constant. Mean should be is equal to the expected value. And the second is limit t tends to infinity 1 by 2 pi minus t to t, x of t dt is expected value of x of t. This is the first one. There is another one is 1 by 4 pi t double integral minus t1 to minus t to t, and x of t1 t2 into dt1 dt2 should be 0. That would make it a mean ergodic process. The next one is Martingale's process. So martingales was optional, but I think it's required for us. Yes, it's required, yeah. So martingale, so and this is a sequence of random variables or a stochastic process for which at a particular time the conditional expectation of the next value in the sequence is equal to the present value regardless of all prior values. So basically probability of xn plus 1 given x1 to xn will only depend on xn. That is the conditional expectation. This is the conditional expectation of the next value of sequence is equal to the present value, which is expected value of xn plus 1 given all the previous values is equal to xn. That's martingale. There's one more thing I wanted to add about white noise was when we take white noise at two values, let's say vt1 and vt2, they would be independent of each other. Probably they are mostly uncorrelated. Uncorrelated is the right term. And then we did mean ergodic and martingale. So I think, yeah, this should be good for homework 2.